Our third lesson in slope fields is called Eulers Method for integration. And so basically in Eulers Method, to build the function, what we're really doing is I kind of think of it as taking like little slope sticks, if you will. And so basically if you know the slope right here from this little piece, you build that little slope field line. And then you reevaluate the slope at this next point right here, and then you build the next piece of that line. And then you reevaluate the slope again for the next piece, and right here at the end point, and you draw that little line. So eventually you're like tagging on all of these little lines to build the entire curve. And so what that looks like is we kind of fill out this table. And so we start with a point X and Y, an initial point to your starting place where you start building your little bridge with your little sticks. And then we're going to find the slope. That's what this box is, finding the slope. And then we're going to multiply our slope by our change in X. So that is like how big that slope piece lasts. And we're going to add it to get our new Y. Add to the original. All right, so what this looks like is we're going to kind of make ourselves a table. So I'm going to start with an X and a Y. They tell me to start at 0, 5. So 0, 5. And they give me a slope equation. So I'm going to say, okay, dy dx is equal to, in this case, x minus 2. So I am starting here with a 0. So I'm going to say 0 minus 2 is negative 2. And then the next step is telling me like how big of a step I have to take. So it says I'm trying to get from 0 to 0.8 with 2 steps. What that means is that's telling me that my change in x is 0.4. My change in x has to be 0.4. Change in x is 0.4. Because again, I'm going a space of 0.8 with 2 equal steps. So I'm going to take my slope m times that space 0.4. So I'm going to say negative 2 times 0.4, and I should get negative 0.8. All right, so then the next thing we're doing, so I have my starting point x, my y value 5. I have found my slope of negative 2. I have shrank that slope value to be just that specific change in x. And the last thing I need to do is I need to take my initial y. So I'm going to say y plus my actual change. So the change there that I just found. So I have 5 plus that negative 0.8. And that's where I'm going to get my new y, which is 4.2. So in the next level, I have went a space of 0.4, so I'm at 0. I went a space of 0.4, so I am now at 0.4. And I know that my new y value there is 4.2. And we're going to do this process all over again with my new x and y. So now I know that x is 0.4, and I'm going to subtract 2. So 0.4 minus 2, I'm going to get a negative 1.6. So I know the slope is negative 1.6, and I need to multiply that by that space, that change in x. So negative 1.6 times 0.4, and I'm going to get negative 0.64. So now I'm going to take my y value that I was at, 4.2, and I'm going to add to it that negative 0.64 to get my new y value, which was 3, if you put this in the calculator, 3.56. That is the y value that we would estimate using Eulers method. So our estimation y of 0.8 is 3.56. So again, let's review that process. The first thing we're going to do is we're going to take our starting point x and y. We're going to find the slope. We're going to multiply the slope by our actual change in x. And we're going to add that change to our starting y value to get our new y value. All right, step B says to actually solve this differential equation. So we'll look at how close we were when we solve it. So we'll move dx over. So I have dy equals x minus 2 dx. We're going to integrate both those pieces. I'm going to get y equals 1/2 x squared minus 2x and then plus c. So we have this initial condition 0, 5. So we're going to solve for 0, 5. So I'm going to say 5 equals, again, I've got a 0, x squared minus 2 times 0, so that's all 0. So 5 is going to equal c. So my equation is y equals 1/2 x squared minus 2x plus 5. And what we're doing is we're going to grab the calculator and we are going to plug in 0.8. So y of 0.8, I'm going to just grab the calculator and see how close our approximation was. If I plug in 0.8 for x, I should get, right, hopefully you said 3.72. So we were not too far off when we solved it all the way out. Okay, example 2, we're going to try this process again. So where we start is with our initial x and y. So it says that y equals 3 when x equals 2. That's our initial point. So I'm starting with 2, 3. And the first thing I have to do is I have to find the slope. So I'm going to say dy dx is equal to 2x minus y. And I'm going to put in my points 2, 3 in for x and y. So I'm going to say 2 times 2 is 4, minus 3 is 1. So I have a slope of 1 at the point 2, 3. Then I have to say, well, the slope is 1, but what am I changing by? So we need to think about what this is asking us to do. I'm starting at 2, and I am going to 1.7. So first of all, my change is headed backwards. And it says 3 equal steps. So I'm headed backwards by a total of 0.3. So my change in x is 0.1 and it's negative. So I'm going to take my slope times that. So this first one's easy. 1 times negative 0.1, I get a negative 0.1. So then the last thing I've got to do is I've got to figure out, well, if I was at 3 and I'm going backwards negative 0.1, where am I at? So my new y. So I'm going to say 3 plus, and it would be a negative 0.1, and I should be at 2.9. So now I'm going to bring that number down to my next layer. I'm at 2.9 for my y value. And my new x value, I was at 2, and I'm going backwards by 0.1. So I am at 1.9. And we do this process over again. So we're going to pause the video. I want you to finish out this table, and you're going to tell me what we expect to be at when we're at 1.7. So you're going to fill in this table, and you're going to say, you're going to give me the approximation for y of 1.7. All right, hopefully you got 2.731. If not, go ahead and pause the video and look at the table and see if you can identify where you went wrong. But again, the process is you start with an x and a y value, you find the slope, you take that slope times the change in x that you are trying to build onto it. So it's not always 1, so you got to think about what that change in x is. And then you take that change in x and you add it to your new y value. So it's kind of like building the bridge as you go. Example 3 is straight from an AP test, and so we are going to use this process to try and figure out all the stuff. So they've turned the table kind of sideways for us. So this right here, this is our slope. This is our y value, and this is our x value. So what I do is I tend to take all of this information and I kind of rewrite the same table that we've been working with. So I'm going to start with an x and a y. So it looks like right here my starting point is 3, 2. And then the next thing in our table is finding that slope. So dy dx. That's also written as f prime. So it's just a notation thing. So that slope is 0.4 at that. So there's nothing really for us to do. I don't have to solve for it. It's given to me on the table. So what we need to do next, though, is we need to kind of fill in the blanks about what the change in x is. That change in x. So it says I'm trying to approximate the value at 2.6, and I am starting at 3, and it says 2 equal steps. So I'm going backwards 0.4, so that means my change in x is negative 0.2. So I'm going to say times negative 0.2, and I have a 0.4 slope. We're going to multiply those, and we're going to negative 0.08. And so what we need to do is we need to say our initial y value of 2, we need to find our new y. My initial y value was 2, and I'm going to add to it my change. So I have plus negative 0.08, and we should get 1.92. That is the y value at 2.8. So now we're going to do this process again so that I can get the value at 2.6. So again, we're going to pause the video. I want you to try to fill in the box at 2.6. We're trying to say 2.6, we're going to approximate, equals what? So you're going to follow the same pattern. The 1.92 is going to come and be my new y. And I have 2.8. You're going to get all the values you need from the table. All right, hopefully you've got 1.78. If not, go ahead and pause the video and see if you can find your mistake. We can talk about it in class.